Hi, and welcome to Concept Based. I'm John Hepworth, and today is on a Year 11 advanced topic. We're in the probability and data section of the syllabus in the probability section. And today's lesson is about multi-stage events, but in the outcome or in the key idea of the multi-stage events, the statement says to use arrays and tree diagrams with multi-stage events. So today I'm actually going to demonstrate the use of a tree diagram. I think a tree diagram is a little less easily understood by students because they're used to drawing tree diagrams with all the branches on them in year 9 and 10. And in year 11 and 12 in this stage 6, we actually draw tree diagrams in a way that condenses the information to make it actually viable to be able to draw. So it's more effective. There are rules that come with the tree diagram, such as multiplying along branches and adding down branches. So we're going to look at that as well. As is always the case, I try and explain all of these concepts with a question. So let's have a look at the question for today. A bag contains 6 green marbles and 4 red marbles. If 2 marbles are drawn out, and it specifically says without replacement, what is the probability of drawing out one of each color? Okay, there is such a wide array of ways in which you can attack this question, and I just want to first of all note what I've said in previous videos about probability. You could do the complementary event here. You could find out the probability of taking out 2 greens, the probability of taking out 2 reds, and take that away from 1, and you would end up with what was left. And the only thing that can be left is the probability of red green or green red. So you can always attack things in a range of different ways. Sometimes complementary events the quickest. As I mentioned, we're going to use a tree diagram today because we do have to be able to interpret them in questions in the advanced mathematics course. So let's go ahead and try and turn this question into a tree diagram. Now, I did mention that we aren't going to put all the branches on. If you look and go 6 green marbles, would you draw a tree diagram that starts with green, 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 and then 4 red? Red, 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 red. The tree diagram would be massive already. And we did do that in year 10, but we're not doing that now in stage 6. What we're going to do is we're going to draw our tree diagram with just the number of branches of outcomes that are possible. The first marble that we take out only has the possibility of being red or green. And then once we take a red one out, the next one we take out could be red or green. And when we take a green one out, the next one could be red or green. And so this is enough. This tree diagram contains all of the possibilities on it that represent, collecting the marbles out of the bag. And you might say, well, hang on a second, there's more greens than reds, and you haven't demonstrated that at all. Well, what we need to do is we need to put the probability of each outcome on each branch. So the probability of selecting red first, there's 4 red marbles, there's a total of 10 marbles, so that would be 4 out of 10. The probability of picking green, therefore, would be the other 6 out of 10. Now, obviously, we could simplify it and make these fractions easy for us, but we're not focusing on that. Now, this next part, without replacement. So when it's without replacement, we have to be very cautious to make sure that we take that into consideration for the next outcome. So if we did take a red marble out first, there's only 3 red marbles left, but there's actually only 9 marbles left in the bag also. So the probability of the second red is 3 out of 9. Whereas there's still 6 green marbles in the bag if we took a red one out first. So that would be 6, but there's a red one missing, so it's out of 9. Then we go down to the bottom part. Greens, we took one out first, so how many reds would be left? 4, so that would be 4 out of 9. And then if we took a green one out, there's only 5 greens left, so there's 5 out of 9. So if we can get the tree diagram drawn with just the minimal number of outcomes that we can on there to keep it nice and concise and get the probabilities onto the tree diagram, we are so very close to actually getting what we're after. All we need to do next is just remember how it is that we use tree diagrams. And I would definitely note to students that when you're using a tree diagram, if you're moving along the branches, then you are going to be multiplying. But if you are collecting a range of branches, you are going to be adding. And the reason for this makes sense because we've spoken about and before, meaning times, and or meaning plus. And when we talk about collecting a range of branches, taking each branch gives us the or option. Is it red and red, or red and green, or green and red? So the or should indicate to us that we are adding. I might even write the word or here and the word and here, just to solidify that concept for us that that's exactly what we're talking about. Okay, now the ones that we are interested in today are the outcomes where they're different colors. So we're actually after the red-green outcome and the green-red outcome. So the red-green outcome, if we move along this branch, we're going to be multiplying 4/10 times 6/9. And then down in this branch, where we go green-red, that is also mixed colors. So we were now going to have 6/10 times 4/9. Now you might recognize something here, and I think it's worth noting. It's not always the case, but it's worth noting. When you multiply these fractions together, the 6 and the 4 at the top make 24, and the 9 and the 10 down the bottom make 90. And it's the same in the other one. 6 times 4 at the top, 24, 9 times 10 at the bottom, 90. So they're actually the same fractions, the results that we're going to get out. So it's when we add them together, we're just adding the same fractions together. So we could just do 2 lots of them, but we don't want to get confused with what timesing means in terms of and what adding means in terms of or. So let's go and add these together because it's an or. So we have 24 out of 90 plus 24 out of 90, and we get 48 out of 90. And with probability, we can write it as a fraction, we can write it as a decimal. If you're going to write as a fraction, you probably should simplify. So this one's going to come down to being 24 out of 45. Now, what you'll notice is that this solution, or the final answer here, is close to a half. And I think we should always ask ourselves a question: does that make sense? In probability, it can be a little bit hard to be like, I didn't expect it to be that low or that high. But if you then go back on all the questions as you're doing them and go, does that make sense? So for example, these are mixed. And the probability is 24 out of 45. So it's just a slightly greater than half chance that they will be mixed. And in the bag, we've got 6 green marbles and 4 red marbles. So obviously there is a big mix of marbles that we've got there. So we probably could expect that we could get a mixed outcome. If we had a bag of marbles where there was, say, 12 green and 2 red, then getting that mixed outcome would be highly unlikely because we'd be taking out so many greens one after the other. So do check and go, okay, the numbers are pretty close to each other, so therefore getting about half of them being mixed outcomes makes sense. And so we're happy to go with our probability of the mixed outcomes being 24 out of 45. So again, just to summarize, when going along the branches, we times, we're saying and. When we go down the branches, we're adding and we say or. When we draw our tree diagram, do not draw every branch. That is far too time consuming. Don't draw an organized list. An organized list is the very, very last thing you draw if you are completely stuck and you have no other option. It's time consuming. If you're at the end of an exam and you just have one question to go and you can't seem to get it and you want to do the whole organized list to make sure it works, fair, use that time. But when you're doing the question in the exam, an organized list is your last option just because they take so long to write out all of the outcomes that you can get. But as you can see, if we do a tree diagram and just put the probabilities on it, it's nice and concise, and we can get that multi-stage outcome. I wonder what would happen to the results if it was with replacement. So we just put one marble in, took it out. We just took out one marble and then put it back and then took out another one. What would be the chance then of having a mixed result? You might want to have a look at what that would be and compare those two and see if that makes sense to you. All right, well, that covers off multi-stage events with tree diagrams. I hope that's clear for you.